Sustainability is a hot topic, and justifiably so. It represents the most important challenge of our lifetimes. Having said that, we've all heard the term over and over again, and when we do this and when we hear it so frequently, it loses some of its very important meaning. So whenever I'm talking about sustainability, I always like to go back to basics and to look at the dictionary definition. If you look it up, sustainability is defined as the ability to be maintained at a steady level without exhausting resources or causing damage. And the thing that I really love about this definition is it shows a very clear link between sustainability and maintenance. So what best oil maintenance practices can we employ that will allow us to operate more sustainably? Well, in this regard, the greatest potential impact is the elimination of unnecessary oil waste. Historically, industrial lubricants have been treated as consumables, but this is very costly from an environmental perspective because it's estimated that every liter of lube oil produced will result in the emission of 3.5 kilograms of carbon dioxide equivalent. Now, thinking about a gas turbine, where the turbine itself will have a lifespan of about 25 years, typically, oils last for about 5 years in these systems, so that means that we need to refill that oil reservoir at least 5 times over the lifetime of the asset. If we can extend that oil life with better maintenance, then we will produce less carbon dioxide as a result of oil waste. So what's the best way to extend oil lifetimes? In this regard, lubricant chemistry management is the best practice available. Lubricant chemistry management employs ICB ion exchange resins to actually manage the oil breakdown products that lead to premature oil failure and death. Using the example of a Frame 7 turbine, it has been shown that ICB ion exchange resins can reduce oil-related emissions from these systems by 320,000 kilograms over the lifetime of the asset. Now that number on its own is really impressive, but where it becomes even more so is when we consider the impact that lubricant chemistry management can have when it is enacted on a fleet-wide basis. So again, returning to our example of the 7E gas turbine, there are about 1,000 of these systems in the world. That means that if we use ICB ion exchange filtration to reduce oil waste in each of these systems to extend oil lifetime by actually managing oil breakdown products, that we can prevent the emission of 320 million kilograms of CO2 equivalent. And that is going to have a significant impact on the sustainability of industrial operations.